Hello friends, today we will talk on sectional orthographic projection, how to draw the sectional views. So before reaching to that topic, the first question which may come in your mind, what is the need of drawing a sectional view? Or you may have a question, what exactly the sectional view means? So I will give you the answer of both the question first, then we will see how to draw them. So first of all, whatever the figure you see here, these are the figures which we have understood in last lecture itself. So we know that this is the cube having a hole on its top surface, which we cannot see from front view, that is from X direction, and from right hand side view. That hole is invisible, or you may call it as hidden. So while drawing the front view and the right hand side view, we have used the hidden lines. These dotted lines are also called as hidden lines. These hidden lines we have used to represent the hole which was hidden when we observe the object from front and from right side. The hole is visible only when we look at the object from top side, which is here. You can see it very clearly in top view. So it is very straightforward to understand that if the hidden things are more, or hidden details are more, then your view will come with more number of hidden lines. And when the number of hidden line comes into picture, then it finds a drawing reader to read the drawing. It's kind of difficult to read the drawing when the number of hidden lines are more, or it makes some sort of confusion while reading the drawing when the number of hidden lines are more. So our aim here is to reduce the number of hidden lines. If you reduce the number of hidden lines from the view, then it becomes very easy for a drawing reader to read the drawing or to interpret the drawing, or in short, it do not create more confusion while reading the drawing. And that is what the main reason behind drawing the sectional view. So what is the sectional view is? So what we do in a sectional view is we imagine that object being cut by some means so that we can see the hidden things. We will take the same example of a cube having a hole on its top surface, which is throughout from top to the bottom. Now imagine that you are having a knife in your hand and you are cutting this object, which is again whatever we have imagined in last lecture as well, that this object is made up of thermocol, kind of a soft material which you can easily cut by a knife. So this object is made up of soft material and you are having a knife in your hand and you are cutting this object along this line. You are passing your knife along this line and cutting the object from top to the bottom. So ultimately what we are doing, we are cutting this object in two halves. If observer is standing here and cutting the object into two halves, then we can say that this will be the front half and this is going to be the rear half. We are cutting this object just for the sake of looking at the whole, which we cannot see without cutting the object. So when you cut the object, when you throw away the front half, then what remains is the rear half, which will look like this, where you can see this hole. Now this is what the section of that object, cut section of that object, which we are imagining. So after taking a section, observer has to look at the object and observer has to draw the view. So what kind of view will be here? I will draw it. So when you observe this cut section of an object from front side, then it will look like this. Right? We already gone through this in fact in last lecture. So this view is not a regular orthographic view, but it is a sectional view. So you can call it as the sectional view. Now, what is the difference do you see in this normal orthographic view or regular orthographic view and the sectional view? Is in sectional view you are able to see this whole. That means you are able to see the edges of the whole. These two edges are now visible after taking the section. So if I want to draw the sectional view of this object, then what will happen? These two dotted lines will be thick lines, thick continuous line. These hidden lines will get converted into thick continuous line like this. So this is which view? It is a sectional view. Before converting this sectional view, which view it was? So it was a regular front view, but now we have converted it into the sectional view, so we must call it as sectional front view. So this is the sectional front view, which is not complete yet. It is half complete. We'll make it complete. So after this, what we do to make it complete? So let's try to understand it. Before that, here, as we imagine that our knife is passing through this line, so that is what we are imagining. So technically that knife term is called as cutting plane. So cutting plane is imaginary plane which we use for cutting the object in our imagination. So cutting plane is also shown with very specific pattern of line. So let's see how to show the cutting plane in the drawing. So our cutting plane, which is an imaginary plane, is passing through this line. So we'll convert this center line into the cutting plane line. So the pattern of center line and cutting plane line is almost same, not 100% same, it is almost same. So this is what the center line pattern is, which is like a long dash, then a gap followed by a short dash, followed by a gap again long dash, and it repeats continuously. So this is the center line, but we have to show here a cutting plane. So we will make the ends of this cutting plane line little bit thick. The moment you the moment you make the ends of the center line thick, now it becomes the cutting plane line, which always associated with an arrows. What is the significance of these arrows, or what it tells us? It tells that when you pass the cutting plane along this line, then the object gets cut into two halves. After that, you have to observe the section in this direction, along this direction. So this arrow tells you the direction of an observer, in which direction the observer has to observe the object after cutting. And many times this cutting plane has a name, AA, or sometimes AA dash, BB dash, whatever it is. So whenever we see this kind of a thing in a 3D drawing, then we must understand that in fact that this line is nothing but the cutting plane, where we have to imagine that we are going to cut the object along this line, and after cutting it we are going to observe the object in this direction. So X was the direction for the front view, and after cutting we have to see in the same direction. So ultimately we have to draw sectional front view. Now let's complete this sectional front view. So sectional front view has a very specific identity, and it is called as hatching line. Hatching line. What is the hatching line? Hatching lines we use to represent the surface. For an example, this is what the random shape of the surface is, and we want to show this surface with the hatching. So hatching lines are inclined at 45 degree. So this angle is 45 degree, and these hatching lines have the spacing between them approximately 2 to 3 mm. So you may represent the surface with the hatching line in this direction, or if you want to show the hatching in opposite direction, you can do this also. Some people feels this easy, some people may feel this as easy or quicker to draw. So now we know what the hatching lines are and how to draw them. Where we use them to draw the sectional view. And I just told you that hatching line is an identity of the sectional view, and we use hatching line onto the surfaces. Now the question is, which surfaces in sectional view we use hatching lines, or which surfaces are represented by the hatching line in a sectional view? It's a question. So this is the sectional view. This is the regular side view. This is regular top view. This is only the sectional front view we are having, and this sectional front view will get complete when we add or show hatching lines onto some of the surfaces. So which surfaces? So the answer is the surfaces which comes in contact with the cutting plane while cutting. Those surfaces we have to represent with the hatching. So for you to understand it easily or to imagine it easily, again I would like you to imagine that this object is made up of thermocol and you are having a knife in your hand, which is a kind of a cutting plane with the help of which you are going to cut the object. So before cutting the object with the help of knife, imagine that you are dipping that knife in some kind of paint, and after dipping it into the paint, you are cutting this object which is made up of thermocol with painted knife. So once you do cutting, so definitely some portion of the object will have paint pasted on it, or some surfaces will get pasted by the paint. So imagine which surfaces will have paint pasted on it. Here you see in sectional front view we see three surfaces. One is this, second one is this, third one is central one. So it's very easy to understand that this extreme left and the extreme right surface will have paint pasted on them, while as this central portion is a hollow circle, your paint or knife will not make a contact with this surface. Your knife will not make a contact with this surface, or the paint will not get pressed onto this surface. So only this and these two surfaces will make a contact with the knife, means cutting plane. So these two surfaces we will represent with the hatching. So you have to measure the angle 45°. I am drawing here randomly, but actually the angle must be 45 with a spacing of around 2 to 3 mm, and spacing must be consistent throughout your surface. So while giving the hatching, whatever the spacing we are using, that spacing is approximate 2 to 3 mm distance. Like this. So now this is a complete sectional view. So this is a sectional front view, this is the top view, and this is the right hand side view. Now here we are not focusing onto the dimension, we'll talk about it later on. After this, as this out of these three, one drawing is the sectional drawing, or one view is a sectional view. So definitely you have to show the cutting plane in one of these view. So you see this AA is a cutting plane. So you can see this cutting plane in two views. One is in top view as a horizontal line, and one is in right hand side view as a vertical line. So you have two options to show that cutting plane. So let's show it in a top view. So we'll make the ends thick like this. So you can imagine this is the object you are having and you are looking from a top view. So you are simply drawing this cutting plane line AA as it is, and I told you it always associated with an arrows which tells the direction of an observer after cutting the object. So this is what the cutting plane. You can show this cutting plane here as well. but no need to show it in both the views. You can show it only in one of the view, either in top view or you may show it in side view. So this is what the sectional view is, and here you can see the previous regular front view was having two dotted lines which are now get converted into the continuous line. So here we are ultimately reducing the number of hidden lines, which makes or which brings some confusion if they are more in number. So this is what the significance or the advantage of the sectional view, and this is how we have to draw it. And that's all for today. Thank you. Take care of yourself. Bye bye.